Good evening, friends. Warm welcome to today's webinar Wednesday program. So we are actually really very thrilled to bring back this initiative for you, aiming to engage to insightful discussions about data center solutions. Today we are very eager to explore the opportunities dealing offers in terms of business and collaboration. So how mutually we can get benefits and partnership to unlock new possibilities in this segment. And this side, Ruturaj, along with us, Mr. Sunil Sinde, who is a seasoned expert in data center solutions and operations, who will later guide us through ELB applications and leaf spine technology and tower switching deployment and its strategies. And following that, again, Mr. Sinde will be deep into the dealing solutions offering accompanied by insightful successful stories. So what we have achieved through data center solutions for many organizations. As you know that the topic of data center solutions, it is very extensive, it's vast in size. But in condensing in our time, so it will be challenging, but still, however, we'll try to our best to deliver key insights within the allotted time frame. The moment we will talk about the data center, what it comes to our mind is it is a physical facility that before that we'll just talk about what is the talking point today is data center overview. So how overall you can just view how the data center is placed, and then what is the evolution and the trends, and then data center industry in India. So how industry is growing in data center business over a period of time in the past 21 to 29, you can see what is the growth rate we are able to see. And then some applications and technology driven data center in architecture wise, and top of racks and the leaf spine network architecture. Then again we'll discuss with following by the data center solution, what offering from D-Link are available today. So the moment we will talk about the data center is what it comes to our mind is physical facility that organization used to house their critical applications and data for the users and then clients. So it generally includes redundant power backup and then power supplies, the redundant communication connections like your backbone networking. So it has to be strong enough to drive your all data on time. So then environmental controls like air conditioning and fire separations and various security devices is part of your data center. So this design is basically computing, network computing and the storage resources, and it handles, it stores and process and manage large amount of data, and often used by organization to host varied applications and services in the data center. So you must be knowing the concept of data center has been around since late 1950 when American Airlines partnered with IBM to create passenger reservation systems. So since then, so the data center is growing year on year, and a lot of modifications as per the services and applications demand. So the main components in data center, if you talk about the IT component, then it is a server and storage, which keeps all your important data, and then networking equipments. So these equipments is basically kind of switches or routers, maybe firewalls, and then cooling and power systems, which always keep your data center environmental proper temperature and provide power to the data center components. And then same time physical security. This includes what is majorly your cameras and access controls and intrusion detection systems that are used to protect the data center from unauthorized access. So you have to prevent, so it should not be any very easy access to your data center. And obviously monitoring and management system also is part of to keep see the performance and the efficiency of the your data center to monitor. And the same time, so you should have the backup and the disaster recovery systems in place to protect all your data against data loss and or maybe system failures. So the evolution, when we are talking about evolution of data center, is been driven increasing demand of for computing and storage, so resources, So data center actually large, centralized, and earlier you can see the data center was very in large size, that the mainframe system must be knowing during 1990 and 2000. So the mainframe computers was there, so which used to be the centralized placed, and it will be, the mainframe were actually the accessed by the terminal located so in other locations. So over a period of time, so this data center architecture has been totally changed. So if you can see, it is distributed and decentralized with the rise of client server architecture. And then, so what is the role? So in the recent year, we can see towards virtualization. Also, it is moving towards cloud computing. A lot of people is moving, so that we can see in the trends, so the cloud computing and then virtualization, how it plays. And then roles of the data center mainly is the reliable location for storing and processing data, ensuring that data is protected from your physical and cyber threats, and high-speed networking for exchange of data between users and systems, and then reducing organization energy consumption by implementing energy efficient technology and practices. So always data center is measured in the kilowatts. So the size of the energy uses, so based on your data center, it is defined. So if you can see the classifications of data center in several types of data centers, it has been characterized in maybe in the enterprise data centers. These data centers are owned and operated by a single organization, so which can support up to the organization internal operations. So that is called, you can say it is enterprise data centers. And then we have the managed data centers, which is basically the operated by third party provider who offers hosting and other related services to multiple organizations. And then cloud data centers, so it provides and cloud computing services and storage and computing and networking to the users over the internet, and maybe the storage and computing networking to the user over the internet they provides. And then co-location data centers is basically it is near to the customer place, where it can be provided space, power and cooling, but again customer can use their own servers and networking equipments. So it is a co-location data centers, and the same time it is been classified with a tier 1, tier 2, tier 3, tier 4. So what he used to call as is the ratings, tier 1, tier 2. So it is tier 1 is basically the most basic level of infrastructure and provide minimal redundancy with availability around 99.671%, and then annually the downtime of approximately, so we can say is 28.8 hours. Same time, tier 2, these data centers offer increased redundancy compared to tier 1 facilities, and then have availability of 99.74% with approximately downtime of 22 hours. And then we have tier 3 networks, so which is called as the multi-layer of redundancy is available to all the networks and then servers and all the storages. So it gives you uptime of 99.98% with downtime of annually 1.6 hours. When you talk about the tier 4, tier 4 is given uptime of 99.999 and 26 minutes only downtime per annum. So it will be getting tier 4 certification of data center. It is very tough. So you have to maintain, you have to ensure all your network and all the servers and components. It is well maintained. So let's move on to, if you look at the data center industry in India. So when discussing the growth of data center business in India, we observe that now exponential growth, compound annual growth rate, what you called as CAGR, at 11% almost from 2021 to 2029. So with expected market of $2.84 million. So data centers are distributed across India differently. The mostly you can find 44% located in the west region, Maharashtra, and then 25% in north and 20% in south and 15% at east. So there is a noticeable shift. You can see the data centers business model from captive data centers to outsourced facilities. So what is basically, we'll talk about the captive data center. So what you used to know, the captive data center is basically single ownership, which captive data centers are owned and operated by a single organization, typically large enterprise and corporations. This organization has full control over the design, and he can provide you the more security and the management of the data center facility. That is basically for your internal use. So when you talk about the outsourced, so this will be what, for the example, if you look at the captive, this thing, so it is basically Infosys, maybe Wipro, you can say Reliance Industries Limited, or maybe Bharti Airtel or Vodafone, or Mahindra and HDFC Bank, Mahindra and Mahindra also. So they use their data center and centrally placed for their uses for internal purposes. When you talk about the outsourced, it is basically, you can say this kind of data centers provide to their multiple users with the multiple services. So like co-location, maybe cloud hosting, and then disaster recovery solutions and managed security services. So those kind of network is called as outsourced this thing. So for example, we can say in top in India is Control-S, one of them, and NetMagic, CP Technologies, WebWorks. So these are the example of outsourced networks. Then we'll see what is the trends available today in market. So this is the top trend of data center, which really driving the data centers. So what is server virtualization? Edge computing, one of them, then hybrid cloud, then artificial intelligence, automation, and intelligent monitoring, and hyperscale data centers, 5G network, chip level security, and green data centers. What exactly the server virtualization is do? Server virtualization is use of virtualization technology. You must be knowing about virtualization in server and the network, which is to create and run multiple virtual servers on a single physical server by using hypervisor. It allows multiple operating systems to run on the same hardware simultaneously. So that is the beauty of this virtualization. So it will be segmented. It is the segmenting all your single server to the multiple servers, but in single hardware. And then same time, what is the benefit you will be getting by using the virtualization? It is allows multiple virtual servers to run on a single physical server. So this is and utilization of hardware resources you can improvise. Then it increases your flexibility and scalability. Virtual servers can be easily created, configured, and easily deployed. So in the quick and easy scale up or scale down response to change our demand. Suppose the network is having the demands more, then you can just scale up your infrastructure, or if it is your demand is less in the requirement, so then you can scale down all your infrastructure. So based on that, it will be very easy virtualization. And then virtual servers can be easily moved to migrated and between physical servers, so that easily you can migrate it, and then it is reduces your hardware and maintenance costs also. So, and then SDDC is one of the virtualization can be used in the software defined data center, and SDN, software defined networking, are two technologies that are often used in data centers, improving your efficiency, and then flexibility and the scalability in the data center. And if we talk about SDDC, so what exactly it does is infrastructure that is fully controlled and managed using your software. So rather than being configured and managed manually. So this is more automated and dynamic management and other data centers resources, and including server, storage, and all your networking equipment. So SDN also is referred to the architecture that you can see the control plane is separated from your data plane. So because what it allows for centralized and dynamic control of your network, and control plane can be managed using same software, and both SDDC and SDN. So can we improve our efficiency of the flexibility of your data center? So these are the benefits you'll be getting by using server virtualization. This is one of the trend mostly used in the data center, and then you'll see that edge computing, how it can play the major role in data center. It is referred to your computing resources and services at the edge of the network rather than in centralized place in the data center. So it is computing the resources and services in location closer to the end users. So it will key benefits will get the improve the performance and responsiveness of applications and services. So increasing data security and privacy. So that is the benefits you will have by using this edge computing, and then reducing operational costs and unlimited scalability, and it reduce your latency also. So it can help reduce the amount of data that needs to be transmitted over the long distance, So then reduce complexity of networking infrastructure. So improve the security and the privacy of data. Data can be processed and stored closer to the source. So this is where you can get the more. So you can see in this diagram. So how the end customer is, data center is placed to the user, near to the user. So get the benefits. Then we'll talk about what exactly the hybrid cloud. Hybrid cloud is a platform that integrates more than one cloud services. Both it can be integrated with public and private cloud. And then to get the best of both the public and private cloud, so now today's the more and more companies are moving towards hybrid mode. So because the private clouds offers excellent control and security, whereas the public cloud will offer the expansive computing powers. So whenever you will need the expand your network, or maybe the infrastructure, or maybe the storage you want to increase, or your power backups, the more this thing, so that can be provided by public cloud. So public cloud is basically the IT model, so where the services are managed by a third-party provider and shared with multiple businesses. Public cloud also give access to everyone, and the price wise, if you look at, then it will be very cost effective at. And then actually, if you look at the live example of public cloud, is basically a Microsoft Azure. So you can consider as a example of public cloud. Whereas we'll talk about the private cloud, it is a computing model where the IT infrastructure is committed to a single user organization. So this is actually the single user organization. It is more expensive than your public cloud services. Not everyone can access to the private cloud because it is reserved to the single user organization. And the example we can say, it is your Oracle is, for example, as a the private cloud is this Oracle services, they give that example we can use. And one of the main benefits of a hybrid cloud is that it allows organization to take advantage of the scalability and flexibility of the public cloud and still maintain the control over certain applications and data. So you can see what is the artificial intelligence uses in data center. So it is many ways you can use artificial intelligence can be used in data center. Some of example you can say it is a predictive maintenance. So when it can analyze the data from the sensors and other monitoring systems. So in order to predict when your device is going to fail. So it can understand faster, and then it can take the immediate quick action to overcome your downtime. Then same time the resource optimization also can be used in data center, including your allocation of compute, storage, and networking resources. So this can help data centers operator to maximize the efficiency of the networking resources. And energy management also optimize energy consumption in data centers. and including the use of renewable energy resources. This can help data centers operator to reduce their energy costs and carbon footprint. So this artificial intelligence, the AI, plays major role in terms of security also. So where the machine learning algorithm can be used to analyze the network traffic and identity the patterns that may indicate to attack. The automation in data center plays, how automation can be used in data center is the technology to perform the tasks without human being. So this includes actually what is the monitoring and controlling of the operations of the data center hardware and software system, same time managing deploying virtual machines and performing maintenance and updates on the data center infrastructure too. So the different applications, different technologies can be used for this automation in a data center, like PLCs and SCADA, Ansible and Puppet and Chef. So these are the automation software. So these technologies can be used in automation tasks such as power management, cooling, and networking, as well as to monitor, control the operation of the data centers hardware and software, both the systems. So it allows more data center to quickly and easily scale up and the same time scale down or response changing demands. So intelligent monitoring. So how intelligent monitoring helps to improving uptime and optimizing capacity utilization, improve people productivity and reducing risk. See, this is actually health polling combined with the threshold, what you can say, and that gives the alert and notifications can help you to identify that to address potential issues, whatever issues are there. So monitoring will help you. So before they lead to any costly and unplanned downtime. And then to improve people productivity also, it increases by during the monitoring. You can so manage all devices, analyze data center business intelligence with the dashboard and the reports, and then make data driven changes, and all in a single system we can see with one click and mouse. So you can see the what is running behind the what is the issues are running and how can you improvise your people productivity in that. And then electronic door also lock, reducing risk by electronic door and control. RFID enables cards, use management and security audit reports can help you to unauthorized access. And then monitoring enables you to centrally manage all devices in your data centers. Allows you to collect data from and configure all your devices via SNMP and HTTPS and other protocols for IP based network. Then one of the hyperscale data centers. Hyperscale data center is very large facility used for storing and processing data on large scale. So it will give you the large amount. It deals with very large amount of data, and it has to be flexibility enough to design and highly flexible with the ability of scale up or scale down to meet the changing demands. Again, same time, it is redundancy. Hyperscale data centers often include multiple level of redundancy to ensure high availability and then reliability also. Because it is a very large companies, they use this hyperscale data centers. It is required more of space and more numbers of servers in place. A single hyperscale data center may include hundreds of miles of fiber cables to connect to the servers used for data storage and networking and computing. And the same SDN also is often used in this kind of data centers for unique software and hardware technologies. And then most of the companies like you can see the giant Google, Microsoft, and Amazon. So those big large companies actually they use hyperscale data centers. The benefits what we'll get by using the hyperscale data centers, because they are in large in size, so they have to have the reduced downtime. So and they have to in the advanced technology where so all the servers and virtual networking technology along with the high speed Ethernet DCI connects to lead to the ultra fast computing and data transport speed also. High reliability levels and the automated self-healing capabilities. And lower capex, hyperscale customers benefits from lease subscribe models that eliminate upfront hardware and infrastructure costs and enable that computing needs that their business to be flexible, scale up to up or down. Then 5G networks. So one of the trend in 5G is the 5th generation that mobile communication popularly called as 5G is finally reality now. The dawn of 5G will facilitate the data speed almost the faster access will give, and the increased bandwidth of lower latency, significantly higher bandwidth and lower latency compared to previous generation of cellular networks. So this can support large number of devices, and then it will be designed in high reliable, and we can import the data centers that need to maintain uptime. The high uptime, you can assure the higher uptime and increased flexibility and enhanced security. 5G networks also incorporated with advanced security features that can so help protect data centers against cyber threats also. So before handing over, so you have any doubts, you can just before handing over to Mr. Sunil, I'll just request you, if you have any queries, so you can just ask. So we'll discuss, then further we'll just hand over to Sunil. No questions? Yes. Sunil?
Yeah, hi Ritu.
Yeah. So please take the lead.
Okay, Ritu. Thank you very much, Ritu, for covering many aspects of data center solutions. And hello, everyone. Once again, good evening. It's pleasant to see you all here here again. Okay. So if you talk about data centers, then yes, in today's digital age, data centers stand as the backbone of our interconnected world. They are the nerve centers where vast amount of data are stored, processed, and distributed. Okay. Then, if you talk about, as we all of us aware that a data center is a facility used to house many computer systems and associated components, such as your telecommunication system, storage systems. In nutshell, it is typically includes the redundant and backup power supplies, redundant data communication connections, environmental controls, etc., and it's in a secure channel. In my session, I'm going to talk more about network architecture and D-Link data center portfolio, where we will see how D-Link will help you, which products of D-Link will help you to set up data center with proper communication channels. For example, D-Link will help you with enhanced data center features, which is required to set up a data center, which is, for example, redundancy. Yes, D-Link portfolio do support redundancy in terms of power supply, redundancy in terms of configuration feature sets, so that if you talk about redundancy in terms of layer 2, in terms of layer 3, then yes, D-Link do support redundancy. In terms of scalability, if you talk about the architecture, should be able to accommodate growth in data traffic and the number of connected devices. So scalability in many times we often achieve through modular design and use of standardized protocols. And D-Link will definitely use all of this architecture to help you with the modular and standardized protocols. In terms of performance, data center network deliver low latency and high throughput to support demanding applications. So if we talk about D-Links, then yes, D-Link data center solutions do give you very less low latency communication architecture. So if we talk about top of the rack architecture, end of the row architecture, or leaf span architecture, then yes, D-Link is the choice for you. Virtualization, if we talk about more, if you are exploring more, then yes, virtualization, data center traffic management. If we talk about security, then all this as a full basket solution, D-Link will provide you to set up a data center solutions. Not less, but today, if we talk about software-defined network, then yes, D-Link will support software-defined network along with the network automation. So network automation is the concept where you can configure or you can address multiples, hundreds and thousands of computers with a single scripting language. Like for example, you have 100 switches in your network. Then you need to, if you want to configure these switches, let us say you want to add VLAN 10 in all 100 switches. Then what you need to do, you need to log into each and every switch, configure VLAN 100 and come back. So this is quite tedious job, right? So instead of this, if we talk about today, then if we talk about today, and then yes, we talk about network automation, where we are giving you a facility to configure the switches with just a single script. Okay, so for example, you are writing a Python script or you are writing a PHP script, then you just have to log in all the switches with a single script. You have to install this script on a server, and this script will keep on running on all 100 computers and shall getting configured with 100 in all switches. So this is just an example I have given. So because today's data center is it requires ease of configuration, ease of communication, ease of management, and that is the reason network automation is very much required. So this is what today's data centers. Now I will just take you through the architecture. Ritu, can you go to the next slide? Yeah. So software defined is basically the same thing what I have mentioned about network automation. So network software defined is basically, as it terms software defined is basically your network which is driven by the software. Software is nothing but any configure, any application which is again written in some Python or PHP or C, C++, Sharp language, which will help you to take the control of your network. So if you have hundreds and thousands of computers or network devices in your data center, then you just need to command this data center switches to route the traffic in particular direction. So today, what we are doing today, actually, we have all of us know that we have OSPF, we have AIGRP, we have IGRP. These are different independent routing protocols. Okay, then every routers or every switch has to configure for this communication. But with the software defined control, you will be configuring all these switches, hundreds and thousands of switches with the script, as I mentioned. So this is what the beauty of software defined network, and is just happy to tell you that D-Link do support software defined network communications with the network automation protocols and with the scripting languages. To the next slide. Next. Because data center involves lots of network devices, there are hundreds and thousands of network devices, switches, high performance switches, edge switches, distribution switches. So to configure all these switches, because data center hosts lots of customers, many customers, thousands and lakhs of customers. Okay, then in case of you're hosting all these customers, then to manage the customers, there are something which what we need is a very fast computing system. So how you will get fast computing system? So compute will get fast when you will compute them at layer 2. So or layer 2 or layer 3. But your communication should be very fast, and VXLAN is one of the protocol which will help you for fast communication between end-to-end node. So for example, if there is a if you're talking about the data center architecture, all of you must be aware that data center architecture talks about super spine leaf architecture. You know, like leaf is the end node which is connected to the servers and storages. So if the information from the server to server communicate with each other, then it should not take more than single hop. And this is the beauty of leaf spine architecture. And you know, like people talks about lots of big architecture, and people and many people thought that this big kind of architectures are supported in particular OEM or particular vendor, but it's not like that. This is the architecture and the protocols which will actually help you to get this architecture done. Just like D-Link do supports VXLAN architecture, so D-Link can help you to build data center architecture with VXLAN with super fast communication protocol, right? So as you see here in the slides, we have overlay network and the underlay network. So underlay network is nothing but all your devices which are connected each other, right? Physically with the wire or wireless. Okay, these are the physical medium which gets connect all the devices. And overlay network is nothing but the network which connects to host. For example, I have customer A which is connected to point in overlay network at switch 1, and another customer which connects to overlay network in the switch 2 same customer. So if these two customer wants to communicate each other, then why should they go with the all hops? Instead, they should go with only one hop, which will minimize the throughput. I mean, which will minimize the time latency, and which will increase the throughput. And that is the beauty of this protocol, VXLAN. So VXLAN is nothing but the extension of your LAN, VLAN. So because VLAN supports only 4,000 VLAN IDs, so 4,000 VLAN IDs are not sufficient enough to configure to take all these hosts, all these computers on a single network. And that is the reason what we need is a VLAN extension, which is VXLAN. VXLAN has capacity to host more than 16 million customers, 16 million VLAN in your network, right? So Ritu, go to the next slide. In the next slide, see, this is what the beauty of what VXLAN is. VXLAN talks about expanding your network VLAN, because VLAN give you 4,000 VLAN IDs. VXLAN will give you 16 million VLAN IDs. Because 16 million VLAN IDs, it is as good as 16 million services, or it is as good as 16 million hosts which are getting connected each other. So this is the reason that VXLAN is getting implemented in today's data center. Apart from that, what is the benefit of VLAN? VXLAN will give you multipathing. Multipathing is nothing but basically host-to-host, switch-to-switch communication. I think in next architecture you will be able to understand how multipath and the ECMP will help you for the equal cost and multiple connection. So ECMP is nothing but equal cost multi-path communication. Like for example, if traffic initiated from source A and to the destination, then from source to destination there will be a multiple paths. Maybe there will be 2 paths, 3 paths, 4 paths, but there will be the data will flow through all the paths. It's randomly. Okay, and that is the reason. If you're it's a super fast communication, what we call in data center. So similar logic, which includes about scaling enhancements. I will just take it to the next slide. Rutu, can you change the slide? So this is basically what I wanted to show you. This is nothing but underlay network, which are like for example, edge devices are getting connected to each other, wire or wireless or any kind of medium, but they are connected to each other, and data will flow directly through all the interfaces. For example, in these 2 edge devices, if there are 100 computers, then data has to travel all these 100 equipments, like 100 switches or 100 routers. Data has to travel. If there is no VXLAN configure. This is traditional method. Next slide. This is the latest trends. This is the latest technology where your data, even though there are hundreds of computers or the hundreds of equipments are connected, but if your edge devices are directly connected with each other with the help of VXLAN BTP tunnel, then this VXLAN is nothing but eVPN, extended VPN. Okay, so it will give you tunnel between the source and the destination, and that is the reason data will pass at the layer 2 instead of layer 3. Yes, Ritu. All right. So deployment of Ritu, click one more time. Yes. So deployment of switches in data center, basically there are two important methods, two important architectures, what we call as a data center top of the rack and the end of the rack architecture. So top of the rack architecture is nothing but the architecture which is shown to you. Okay, in this architecture, all your servers and the storages, as shown in this diagram, all your servers and storages are connected to the top of the rack switch. That means there are two switches which are connected at the top of the rack. Okay, and these switches are connected to each and every servers, so that if one of the switch fails, there is another switch which can take over. So these two switches are not only connected in active. These switches are not connected in active backup, but they are actually active, so that data can visit it through both the data can travel to both the switches. This is what the beauty of top of the rack, that it's give you higher throughput and it will give you redundancy at the same time. Yes, Ritu, next slide. So this is the module. This is the switches that actually the display for data center solutions by D-Link. D-Link will give you two kinds of solutions for data center. One is a 24 port and another is a 48 port. So if for 24 port, D-Link will give you DXS F3428SC, which will give you 24 number of 10 Gbps ports and 4 number of 100 Gbps ports. Then we have Ritu, go to the previous slide. Then we have DXS F3610, where we have two variants, which will give you DXS F3610 54S and DXS F3610 54T. So 54T is nothing but a switch which will give you 48 10G copper and 600G fiber. 54S, that is DXS F3610 54S, will give you 48 number of 10G fiber and 6 number of 100G fiber for the communication. So 48 10G fiber can be connected to the servers, or 48 10G copper can be connected to the servers, and rest of the ports can be connected to the uplink. Okay, so I want to go to the next slide. So this is what the front panel of DXS F3610 series, like where you can see there are 48 number of fiber. So decisions of this fiber or the copper switch can be made on your server requirement. For example, if your servers do require copper port, 10G copper port, then you go for DXS F3610 54T. If your servers have fiber ports, then yes, you can go with the DXS F3610 54S. So we have the solution for both the requirement. So nowadays server comes with the 10G, 25G, and the 100G. So mostly server comes with the 10G and the 25G interface. But if you talk about sub rooms, server rooms, or data center architecture, then most of the servers are with the 10G BPS interface only. So D-Link product line for these solutions will give you two variants as shown in this picture, pictures. Okay, this is completely non-blocking architecture. The beauty of these products is basically fully non-blocking architecture. That means there is no any blockages in forwarding the data traffic. Okay, if it's a completely cross architecture. So that means cross means is basically architecture. It's the latest trend of architecture where there is no blocking whenever you are forwarding data from any edge to any edge. Or within the hardware also, this is completely non-blocking architecture. So 6 number of 100 Gbps ports in both the model are given for uplink connectivity or switch to switch connectivity, or it can be switch to router connectivity. So both the things are very well defined with the fan module redundancy and power supply redundancy. So because if there is a failure because if you see about data center architecture, then yes, there is a power rack 1 or there is a power rack 2. So because the power from both the sources are coming from different power source, okay, so that if one of the power source fails, then the second power source is still there for data center, because that is the reason data center known for 99.999999% SLA. That means there are very less chances that the failure of data center network. Have you heard of failure of any data center network? No. So there is no any. So data center network will not easily. You will find it's not collapsible networks, and that is the reason, because so much power, so much things are already taken care while designing the data center network. And D-Link will give you power level redundancy as well as fan level redundancy. Both the redundancy are given by D-Link switches. Rutu, next slide. So this is some of the architecture which we draw with the help of data center architecture. Okay, these are the server storage high performance servers which are connected here. These servers, as in shown in the diagram, these servers are connected to both the switches. Okay, and both the switches, this complete equipment along with switches and the storage are installed in one rack. You can visualize that, and these racks switches which are at the top of the rack will connect it to the next rack. So in this way, if you take about 20 such racks, then 20 such uplink of 100 Gbps will connect it to the main switch. That is basically architecture of data center. Okay, go to next slide. So the same thing here with the help of 24 and the 48 port options. D-Link will give you 24 port and the 48 port hybrid architecture for the server and the storage connectivity. As shown in the diagram, you can see that all the 10G DXSF 3428 SC, which is 24 port 10G and the 4 number of 100G switch, is connected to both server storages. Okay, and we also have option of 24 48 10G SFP plus to connect servers and the storages. So this is a hybrid architecture including 24 and 48 port, which is available with us with D-Link. Yes, Ritu, next slide. So this is what actually I wanted to tell you. At the end of the row, you will find all this top of the rack switches are getting connected to the end of the row, and this is basically connectivity on the 100 Gbps, and the 10 Gbps is basically top of the rack to the servers, and top of the rack to end of the row connectivity is on the 100 Gbps. This is what full data center architecture is. Now, why this kind of architecture is? What is the reason for being this kind of architecture? If you wish to understand that, okay, then I will just tell you the reason on the next slide. Yes, Ritu. This is the reason where I wanted to emphasize why actually the reason is. You can see that leaf, the bottom of the switch, leaf is basically connected to the server and the storage. So this leaf, you can see this leaf is connected to all the spines. Spines are, you can understand, spine is nothing but a distribution switch. Okay, and this spine is then connected to the border leaf. So border leaf is nothing but super spine, okay, which is again connected to 100 Gbps or 40 Gbps. So this kind of architecture, you can see that if I want to send the data from leaf 1 to the last leaf, then you can see how many devices are there in between. Though you can see here 50 units of devices, 50 units of minimum 50, 40, 50 devices. But if you're sending the packet, if you're sending the data from leaf 1 to the last leaf of the server, then you will have only one hop, only single hop. Why? Because all leaves are connected to all spines. Now, because every leaf is connected to all spine, okay, every leaf is connected to all spine, and every spine is connected to all leaf. The data have only single latency. There is no latency increase, and the throughput is very, very, very high because of this architecture. Because the reason is if we talk about traditional three-tier architecture, where we talk about core, distribution, and the access communication, okay, we always see it from the northbound and the southbound perspective. But if we talk about leaf spine kind of architecture, then you can see from east-west traffic perspective. East-west means the traffic from leaf to leaf, because maximum data transfer is in data center happens from east to west, not from south to north. Okay, south to north, basically, if we talk about campus network, then you have core, distribution, and the access. In the campus network, maximum traffic is destined towards the internet, and that is the reason it is south-north bound traffic. But if we talk about data center, so data center may it will be the traffic will flow from servers to storage, storage to the server, and there are many inbound load balancing protocols which are happening in these spine switches. So that is the reason the traffic for data center at least is from the east to west. And because of this reason, there is a maximum of communication between the leaf to leaf and the spine to spine. And this is the reason this architecture comes into picture. I hope this information will be very much meaningful to you, and I'm sure you definitely gain something out of today's session. Okay, Ruth, can you go to the next slide? So along with, I just wanted to convey, we are not going in detail. Okay, I will just tell you because of time crunch. I will just tell you in nutshell, like switching is what we have talked about today. Okay, but along with switching, then yes, we do have fiber and MPO cassette connector. Then we do have structured cabling. We do have network enclosures like smart racks. Okay, so D-Link do have complete end-to-end solutions for in terms of data center perspective. For fiber and the MPO perspective, yes, D-Link will give you single mode and the bunch of single mode and the multi-mode fiber optics. We do have, because fiber in data center mostly mostly people go with the multi-mode architecture, and for data center, because 10G and the 100G speed is required, D-Link will also support you with the OM1, OM2, OM3, and OM4 fibers. So in OM4 fiber, D-Link will give you in multimode fiber, D-Link will supply you with the OM3 and the OM4 fiber communications, which will give you up to 10 and 40 and 100 Gbps of transmission communication. For the MPO, yes, MPO cassette connectors will give you information, more insight on the data center rack management. So if you want to manage your cables within the rack, okay, then the rack to rack communications, rack to rack connection shall be done on the MPO cassette connectors. So D-Link will give you 24, 48, 64, 128 out to 56 cassette connectors from rack to rack tracing. So that is also available with D-Link. Apart from that, structured cabling, yes, structured cabling is very broad term, but whatever information which is required for Cat6, Cat6A cabling termination, yes, starting with the cable to all accessories, including patch panel, keystone, jacks, and like everything is available with in D-Link portfolio. Finally, nothing but racks, network enclosure. Yes, D-Link do have smart racks kind of racks which will give you biometric authentication, which will give you which will give you racks with the AC, air conditions, which will give you racks with the management facility. Like for example, if you have installed the rack in some environment where there is no air conditioned room, yes, but then D-Link will supply you the racks with the dual air conditions, okay, and the facility to manage these ACs and the power inside the rack. So D-Link will give you racks with the intelligent PDU. D-Link will give you the smart rack with the AC. D-Link will give you a smart rack with the CCTV to manage, to understand the who is actually accessing this rack. D-Link will also give you biometric authentication, and that is the beauty of D-Link, which will help you to give you end-to-end solutions for the data center kind of requirement. Maybe sometime later in future we will talk about data center components, this data center components. And for today, I think I have done with this technologies for data center. If anyone has any questions, you may please go ahead.